So we're going to solve quadratic. So when you solve a quadratic, a couple things have to be met. The first thing that must be true is your expression must be in factored form. So if you have a quadratic that's in expanded form, you will have to factor it. So if I'm looking at these problems from here down, so these 4 problems, I'm going to have to factor before I can solve them. The other condition that must be met is that the whole expression must be equal to 0. It must be equal to 0. So these 2 down here, neither of these are equal to 0. Therefore, I'm going to have to get them equal to 0 first, then factor, then solve. So that's going to be our protocol. Factor, then solve. All right. So for the first one, we have 15n times the quantity n plus 15 is equal to 0. Here's what's happening. We have one number right here, and then we have a second number right here. So when you're multiplying 2 numbers together, and it's equaling 0, what must one of those 2 numbers be?
Zero.
0, right.
Oh.
So one of those 2 numbers must be 0. Does it matter which one is 0?
No.
No. Therefore, either of them can be 0. So we have 2 possible answers because we have 2 variables. So to solve this question, I'm going to rewrite it and break it apart. So I have 15n is equal to 0 because that n can equal 0. And I'm going to have n plus 15 is equal to 0 on the other side. So let's deal with our first problem. 0 is equal to 15n. What's the opposite of multiplying n by 15?
Dividing.
Dividing by 15. Dividing by 15. So 0 divided by 15 is 0. So we have 0 is equal to n. On the right side, what are we going to do to both sides to get the n by itself? Subtract 15, right. So we subtract 15 from both sides of my equal sign. And I get n is equal to negative 15. So I end up with 2 answers.
But which one is correct?
They are both correct. N is equal to 0 and negative 15. And if I were to have graphed this, I would have had a parabola where the parabola went through, I'll extend my x-axis, the x-intercepts right here. This would be at negative 15. This intercept would be at 0. So my solution to a quadratic is the x-intercept. Incidentally, it's also called the root sometimes. Okay? So roots, solutions, x-intercepts are all the same thing. So looking at my next problem, I have y plus 5 times the quantity y minus 7 is equal to 0. So we already have a factored form expression. It's already equal to 0. So let's find out what y is equal to. So again, we have 2 numbers. Here's one, here's the other. Either one of them can be equal to 0. So, Allie, what will I do for this one?
Okay, so first on the 0 equals y, a quantity of y plus 5, what you would do is you do minus 5.
So I'll subtract 5 from both sides of the equal sign.
And then that gives you negative 5 equals y.
Okay.
And then on the quantity of y minus 7 equals 0, you would do plus 7 on both sides, and then that would give you y equals 7.
So I have 2 answers. Y is equal to negative 5 and 7. And if I were to have graphed this, I would have had my x-intercepts would occur at about negative 5 and positive 7. So this would be negative 5 comma 0. This would be 7 comma 0. So far so good?
So far, so good.
Okay, if I feel as though it's important enough to write down, you think it's important enough to write down. I know. I wasn't talking to you. Okay, all right. All right, so now for my next question. My next question, I don't have 2 variables. I have 1, 2, 3 variables. Therefore, there are going to be 3 possible answers. We have 3 possible answers here.
Oh, I know how to do it.
So, just because there are 3 possible answers doesn't change the process. The process will remain the same. I'm going to break it into 3 separate parts. So over here, we have 0 is equal to 3x. What am I going to do to both sides to get the x by itself?
Minus 3x.
No, what's the opposite? So right now we have 3 times x. Well, we're going to divide both sides by 3. Divide both sides by 3. And so I get 0 divided by 3 is 0. So 0 is equal to x. Write it down.
Yeah, Nick.
All right. So that's one of my 3 answers. Incidentally, if you have a monomial with a variable, that's always going to have a solution of 0. Always. But for my next one, I have 2x plus 1 is equal to 0. My board is misbehaving immensely. All right. So I have 2x plus 1 is equal to 0. What am I going to do to both sides to get the x by itself? Yes?
Well, you first have to get the 1 away, so it's
Right.
minus 1 on both sides.
So hold on a second, let me do that. So I'm going to subtract 1 from both sides. So I have 2x is equal to negative 1. Okay.
And you divide by 2 on both sides.
I'll divide by 2 on both sides. All right.
And 2 divided by negative 1 is negative
1 divided by 2. 1 divided by 2 is not negative 2. 1 divided by 2 is, it's a fraction.
2.
Negative a half.
Negative.
Yeah, negative 1/2. So I end up with x is equal to negative 1/2. I can get fractional answers here, that's fine. And then finally, for the last one, what am I going to do to both sides to get the x by itself?
Minus 5.
I will subtract 5 from both sides. So what am I going to get, Nick?
You get 0.
That's 0, okay, but I still have this 2x that gets brought down.
And so then I get negative 5.
I'm pretty sure you're right too. All right, so then what am I going to do to both sides to get the x by itself? Sam?
Divide by 2.
Divide by 2, divide by 2. And so I get x is equal to, and let's keep it as an improper fraction, negative 5 over 2. And so so the answer for this one is going to be x is equal to 0 and negative 1/2 and negative 5 over 2. Now it would probably be a little more proper if you put this in ascending order. So it would probably look a little nicer if you had negative 5/2 and negative 1/2 and 0, since 0 is the largest answer here.
If you wrote it like that, though, would you get points taken off?
Hey, I'd be just pretty stoked that you got the intercepts, okay? So if I were to graph this, I would have a graph that would look like this. I would have something that looked like that, where this point here is negative 5 over 2. This point here would be negative 1/2, and this point here would be 0. So again, we're just looking for x-intercepts. Yes, Sam?
I don't understand how the fractions work in, like, with the graph. Like, it doesn't make sense.
So your number line, your number line on your graph has all the numbers you can think of. It has whole numbers, 1, 2, 3, -4, -10. It also has fractions in between those whole numbers. And the graph is allowed to cross the x-axis anywhere on it. It doesn't have to be at a whole number. Okay? All right, so I'm going to clear this, and we're going to go a little bit further into our factoring adventure. All right, so in the first 3 problems, they were all in factored form. This problem is not in factored form, is it? So we need to factor it. So Allie gave us this problem, so how am I going to go ahead and factor this problem? Oh, she wrote the problem. Maybe she can help us out here. You want to do it? All right, come on up.
Okay. So first what I did was I checked on my folder and saw if it had a greatest common monomial, and it didn't, or a difference of squares, and it didn't, or a squared binomial, and it didn't, or a binomial pair of factors. And so what I did first off was I did the rectangles. Oh, hold on. Okay, I did the rectangle, and we already knew that this was x and this was x squared. And then, hold on, let me find the other pen. Where's the other pen? Oh well, and then this one. Okay, got the pen. This one was 17. So then we were trying to figure. Oh, 30. Sorry. Okay, this one was 30. So then what went into 30 but equaled 17. Positive 17 and positive 30. So there was 15 and 2. So this equals 2x and 15x. So then if we wrote this out into factored form, it would be x plus 15 and then x plus 2. So then after that we would do 0 equals x, oh wait, yes, x squared plus 17 x, oh hold on, let me write that down here. 0 equals, that's factored form. And then
so we've done a good job of getting it into factored form. 15 times 2 is 30. 15 plus 2 is 17. So now that we have it in factored form, we know that x plus 15 times x plus 2 is equal to 0. We have it in factored form, and we have it equal to 0. So we can go ahead and solve. So let's break the binomials apart, set each side equal to 0. And so what are we going to do on both sides here to get the x by itself?
Subtract 15.
Perfect, Stella. Subtract 15. Subtract 15. And so I get negative 15 is equal to x. On this side, what am I going to do to both sides, Ava?
Subtract 2.
Subtract 2, subtract 2. And I get x is equal to negative 2. So for this expression, x is going to equal negative 15 and negative 2. We're done. Let's take a look at the last two. So we have f squared plus 9 is equal to 10r. And this fails on all accounts. It is an expanded form, and it is not equal to 0. So first thing we need to do is we need to make it equal to 0, and then we can factor it. So what am I going to do to both sides to move this 10r, because we need to move it. Margot?
Divide by 10? Just kidding, that get you 1.
Without right.
Subtract 10.
Subtract 10r, exactly. So we're going to subtract 10r from both sides. Oh, shoot, this should be an f. My fault. That was always an f. So we're going to subtract 10f. Do we have any other plane f's? Do we have any other plane f's? We have f squared, but do we have any f's to the first?
No.
No. So we have f squared minus 10f plus 9 is equal to 0. So now we have a quadratic that is equal to 0, but it's in expanded form. So now we have to take that expanded form expression and turn it into factored form. Ava, what is this going to be as a factored expression?
Well, you first do it as rectangle.
You do it as a rectangle? Okay.
No, you couldn't.
Wait, is writing it as like they both have to be negative.
They both have to be negative.
-1.
Remember,
Oh.
so what is the area of this rectangle right here?
X squared. S squared.
F squared. What's the area of this rectangle? It is 9. So we know that this length is f. We know that this length is f. What's this length here going to be? 9, and this is
-9.
and this is going to be 1. Okay, and -1. So the area of this is -1f. This is -9f. Excellent. So, and when you add -1 and -f, you get -10. So we have f minus 9, which we got right here. We have f minus 1, which we got right here. And so now we're able to solve this. So let's set each one equal to 0. So we have f minus 9 is equal to 0. And we have f minus 1 is equal to 0. Break it. So what are you going to do to both sides to get the f by itself?
Add.
Add what?
9.
Add 9, add 9. So we get 9 is equal to f.
Got it.
Over here, we're going to add 1, add 1. And so we get f is equal to 1. Are there any questions so far?
Great